To the internet. Utmost pleasure to introduce Brian Moon. I've known Brian for going on maybe 4 years now, ish. Brian runs an excellent site called Deal News. Before there was Guilt Group, before there was other group on Flash, holy crap, something's on sale and this is awesome. There was Deal News, and he's got lots of excellent battle scar stories. And he's going to be talking about Gearman. Gearman is something we use here at Etsy, quite a bit actually, for processing asynchronous work. So, further ado, Brian.
Thanks, John. All right, so John did a pretty good job of telling you who I am, so don't have to go through that. Always want to do a pie graph in a presentation, so I thought I'd throw it in here. We're going to spend most of our time talking about how Gearman works and what our use cases are for it. If you don't know what Gearman is, this is how Joe Stump describes it, who is former lead architect at Dig before they made some mistakes in their architecture. I was going to put that on the slide, but I thought it best not to. So if you have any knowledge about how forking a process works in an operating system, then that's sort of what you're going to do with Gearman. You're going to spawn off work to be done other places than where the current work is happening. There's three main components to the Gearman protocol. The client needs something done. Workers know how to do that work, and Gearman D is the thing in between that makes sure the work gets done and gets sent back to the client if needed. Like I say, Gearman D is he just organizes and queues up your stuff so that it can get done in an orderly fashion. It's a separate daemon. It's not part of your code base. It's a separate daemon that's running. The client gives it a unique job ID and whatever the input data is that it needs processed. It then gives that work to a worker that will do the work for you. The workers are constantly running. I'll talk about them in a second. The other part, the part that most developers are going to write is going to be the client. Clients will connect to a Gearman D server and ask for work to be done, give it a job ID and a payload. The client can either fire and forget and make it a background job and just continue whatever it was doing, or it can block and wait for the work to be done and wait for a response. It can also send multiple jobs to be done at once and wait for the response from all those jobs to come back. Workers are where the heavy lifting happens. This is daemonized code running either most likely on a separate server or a separate architecture somewhere away from where your current code is writing as a developer. Single workers, a single running process can know how to do one job. It can know how to do 20 jobs. It's however many jobs you want that one worker to do. It can advertise that it knows how to do those jobs. And one of the big features of Gearman is you can write the worker code in a whole other language than you write the client code, because all you're passing is a job ID and a binary string of data that has to be interpreted. You just have to know how to interpret that string of data on both sides. So that makes it, there's some good opportunities there if you're working in an environment where you're restricted by your language. So the key features that make Gearman very interesting are that it can do background jobs, which means you can just ask for a job to be done, and then you don't care when it gets done or what the answer is. You can just have work done for you in a background manner. You have de-duplication of jobs. So the job ID that you give to Gearman D is a unique identifier that represents that job. If another client requests work to be done with the same job ID, Gearman D will ignore that second request. That is to say, it won't have that work done twice. If it's a foreground request and two clients ask for the same job, it will have both of those clients wait for the one job to be performed, and then we'll give that answer back to both clients. So it's a big win if you have a lot of problems, which one of my use cases is de-duplication of work, to not be doing the same work when multiple clients need it. Jobs can have high, normal, or low priority. This was a big debate. At one point it was only high or low. Actually, no, it was only high or normal, which doesn't make a lot of sense. I was one of the people who was pushing for the third priority, and we pushed high, normal, and low priority. We'll talk in a minute about exactly what that means for each, for how things are queued. And the last thing is, work will be resubmitted to another worker if the worker dies. So if your client asks for work to be done and the Gearman D server gives it to a worker to do, and then that worker quits responding with the manager server, he will then give that job to someone else to do, to another worker to do. This is configurable with the Gearman daemon to how many retries you want to happen. Obviously, you want to set that to something sane, because otherwise he'll just keep giving out work, and you'll just keep, if you have a seg fault in the worker code or something, you'll just loop forever, which there's a reason that option is there, because somebody did it. I've done it. Yeah. So yeah, those are the key features that I really think are important in Gearman. So background jobs, I'm going to go into a little more detail about each one of those features. Like I said, clients can fire and forget. It's immediately code processing immediately returns back to your code. This is well suited for data marshaling, which I don't know if this is how Etsy uses it or not, but we use this for data marshaling a lot, where we want to just say, hey, this article changed. I need you to go do stuff to it, but I don't really care what you do. I just know I changed it, so I need you to go do whatever it is you do that are the business rules for when an article changes. The downside of background jobs is you don't really know what their status is. The way Gearman operates from a statistics and looking inside of it point of view, you only really know what's happening right now. So once a job's done, its ID is gone. You can't check on it after it's done. While it's running, you can ask for a status, and it will give you back anything it knows, but it's up to the worker code to actually tell the manager server how much of the work is done. So if the worker code is not written to communicate that information, then only thing you'll know is that the job still exists. You won't know if it is partially complete, how much of it's 50% done. You don't know any of that unless the worker code's actually written to tell the manager. So de-duplication. Like I said, you provide the unique job ID. By default, I think the C library by default doesn't create a job ID based on the payload at all. It just generates a random ID. So you probably want to check with your particular library to find out if you need to be assigning an ID or not. Some libraries use the payload and the job name to generate an ID if you don't provide one. Other ones don't do that, so that's something you have to watch out for. If your library, your client library, provides you a way to assign a unique ID, you probably want to. So if more than one client, even if it's a background job, if one client asks for a background job to be done, so they're disconnected, and then a foreground job request comes in from another client for the same job, he will still connect that foreground job to that waiting output, and will return it if it comes back. So it doesn't have to be all foreground, doesn't have to be all background. However, as soon as that job is done and sent out, it's gone from the queue, the result is gone. So if a millisecond after the job is done, another client comes in and asks for that same job again, the work's going to happen again. So it's not a cache, it's not a, there's no caching involved. There's been talk about adding a caching option for results to Gearman as a plugin, but I don't think there's been any movement in that area. Say that again? While the work's being done, right? The de-duplication process only happens while the work is being done. Once the work is done, the job goes out of the queue completely, and Gearman manager, the Gearman D doesn't know anything about it. One got you with priority, which is the next slide. So I'll go ahead and advance with priority and the de-duplication. If you submit a low priority job and you're waiting for the answer, and another client comes along and submits the same job ID, however with high priority, because the job's already in the queue, it's going to be low priority. Priority is not upgraded, and priority is not part of the unique ID. Well, it's not part of the unique key for a job that's in the queue. So what we do is we actually make priority part of our unique ID. The wrapper I've written in PHP for our client, the priority is part of the key we generate. We just do a hash of the payload plus the job type plus the priority. MD5 hash, that's our unique job ID. So that keeps us from having that problem. The work will get done twice, however. So if you have workers that should not be run at the same time because they're conflicting for resources or writing to the same files or anything like that, you can't do those type of things lightly because you will cause yourself some problems. So the big thing about priority is understanding how it fits into the queue. The queue is a first in, first out queue for the most part, with the exception of priority. When things, if there's, let's say you've got 10 highs, 10 normals, and 10 lows, and you submit a high, it's going to go at the end of the highs, which I think pretty much everyone expects that behavior. I think the Perl daemon, the original Perl daemon, originally would just stick it at the top of whichever queue it found, but I think that's been changed in recent years because that was seen as a bug. The other thing about priority is, and the queue in general, is it's all per job type. So if you have article change and you have article alert, which are two of our job types, they have separate queues. So if you have a worker that knows how to do both article alert and article change, those aren't going to be merged. The next article alert comes available. Well, okay, that gets into actually talking about how the queue works, which is the next slide. You think I planned this? Within a job type, okay, the worker is picked to do the work using what I call the game show method, which is essentially like Jeopardy. First, the Gearman D sends a wake up out to every worker that knows how to do that job type, and the first one that he gets a connection back from, he gives the job to. Okay? So, and everybody wants to know, well, how do you load balance your workers, and how do I, make sure that all my workers are getting work? And it's like, you don't need to, because if a worker server is loaded, he's not going to respond first. If he's IO bound, or his CPU bound, or there's something really bad going on, he's not going to be the first one to respond under most normal situations. Now, one downside to this is if you're running workers in a LAN environment, and then you have some workers that are connected over a VPN or something. The ones over the VPN are never going to get work, ever, never, ever, until every server in your local area network is busy, because they'll never respond first just due to latency. So latent networks can cause some problems with your expectation about how work is going to be distributed. The last part is when you have a single worker process that knows how to do multiple jobs, the order in which he will be prioritized for work is directly affected by in what order he advertises what he knows how to do. So if he knows how to do 10 jobs, job 1 through job 10, and there are, in the queue there are 10 job 1s and 10 job 10s. What's going to happen is the way the queue processing works, he goes through what work knows how to be done, which in order of how they added them when the worker connects, he sends, I know how to do this job, I know how to do this job, I know how to do this job, and do this job. So basically what will appear to happen, which will actually what will happen, is all those job 1s will be cleared out before the job 10s start getting done, because that's the first job in that worker's list of advertised jobs. I tried to figure out how to visualize that, and I couldn't figure out how to visualize that, and it's not even really easy to explain out loud. But basically, okay. Yeah. Yeah. Yeah, right. Yeah, that's the same here. Yep, same here, yeah. What we do is we have, and you guys use Gearman Manager, so you probably may know exactly what I'm talking about. The way I made it was we have X number of jobs that work processes that know how to do all jobs, and then we can dedicate this many processes that only do this job. So we always have this little buffer of workers that only know how to do one job. So anytime there's a conflict, there's always a worker free, most likely, to do it. And it's only when you get a burst that you really utilize those workers that know how to do a lot of stuff. Yeah, that would be another possible. There's going to be something. I mean, it depends on how many work. I guess if you have enough workers going, that most likely will make it so that you're good to go there. I should probably just add that to Gearman Manager. Or you should probably submit a pull request. Oh, okay. That's handy. Where's my pull request? Yeah. So I talked a little bit about operational visibility. This is probably the one area of Gearman that I'm least happy with. You can, like I said, you only can ever see what's happening right now in the Gearman D server. You can't see, there's no counters for how many jobs have been done, not even a total count of total jobs, much less a count of particular work that has just been done. So I think Etsy does the same thing we do, which is you do it externally outside somewhere. I actually have a hack in our version of Gearman Manager that updates Graphite via StatsD now with counts of all our jobs, so we know how many are going. So that's the one area where I'd really like to see some movement, and I've been told if I buy the right support contract, I could probably get that done. So maybe we need to get together and pony up and see if we can get Data Differential to write that code. All right, the next 4 sections here are the 4 use cases we have for Gearman in our architecture. Most of it is background processing, except for the last part, which is the most mission critical, which is actually pretty much most web requests that go through Deal News involve Gearman. This is the way we used to do things. Everybody probably recognizes that. That doesn't last long and eventually will fail. Of course, before that, there was no Memcache D. It was just this, and that really failed. So, a few years ago, we got the bright idea to do this. And this worked pretty well. We created this optimized database and used cron and some triggers and some stored procedures and about 10 different possible ways you could actually get data to move from one to the other, and it would get out of sync, and So the big issue we had here also was this cron process. So what we did was we had a trigger that anytime an article row changed or any of the tables that involved an article, it would insert a row, that article ID, into a MySQL memory table of all the articles that have changed. Then a cron job would run every minute and pull every article out of that table that had changed, and then run through the cron job and sequentially grab all that stuff. What we saw in our cacti graphs for the database server was every 5 minutes, which is the schedule at which we update the hotness value for the deals on our site, would go, every 5 minutes, this guy would go through the roof, I would go through the roof, because it was selecting 300-400 article rows all at once. And it would cause these little mini hiccups if we had our full 25-man content team all writing content at that exact, like the middle of the day, which is the worst time of day it could happen, when all of the content team is trying to write articles, and we're trying to read everything from the database, and we're into year 4 of our 5-year server, plan for this server. It's not due to go out of service for another 5 years, and we started tracking every visitor and putting that in the database and running reports on that too, which that wasn't in the plan 5 years ago. But so we would have these little spikes that would cause us problems, and it sounded crazy at first to some people in the organization that having a system that would be event-based and actually select data from the database server whenever we wanted to. In their minds, it was just whenever something changes, you're going to run queries, and wouldn't it be much faster to always know what you're going to query and how often it's going to be? And it turns out it wasn't. It was actually much better and more healthy for our systems and created much smoother graphs and a much smoother experience, and our server had many less spikes, and data stayed in the DB buffer pool much more consistently if we were just constantly reading and writing the data rather than reading it in little spurts every 5 minutes. So now what we have is our code base. On our back end, we use object relational mapping. We don't use it on the front end, but we use it on our back end. We kind of have two worlds we develop in. And so we can handle all of our business rules in the ORM, and when an article is saved, we fire off a high priority article change job for that article ID. And so anytime anything on our back end changes that article, we fire off a high priority Gearman job. And then we have other processes, like calculating hotness every 5 minutes, that they fire off normal priority jobs. So what this means is if a writer writes a new piece of content, it has higher priority over the things that are just getting their little 4 balls updated, which most of the time they're set after 30 minutes and don't change the rest of their life. So it's really not that critical. This let us update the things that need to be updated while not doing things that were bad, like in the middle layer here where we make we do some transformations of data. If the rules for how we transform data change, we would have to do a full requeue, repush everything to the front end from the back end. Well, in the old world, if you did that, you were just kind of up a creek, because it was just going to start updating everything, and somebody writes a new article, it's at the bottom of the row, and you're just kind of hosed. And so now we can actually do a full requeue and put everything in as low priority, and you look at the queue and you refresh our status page a couple of times, you're like, okay, it's going to take 4 hours. It's going to take 4 hours. Every article is going to get repushed out to the front. If anything gets saved, it's high priority. If anything gets changed by a normal back-end process, it's going to be normal priority. It's going to go in front of this stuff, so everything will get updated, and it all works great. The servers are happier to be constantly used rather than being sporadically used. This just works. We did it as a test for one particular type of content, and we just kept going until this is the only way to push something from our back end out to our front end now. So I think I just covered this entire slide. This is one great thing, though, right here. Because when our writer hits save, we immediately fire a high priority job. By the time they can switch tabs and hit reload, the deal's on the site, right? So to them, it's real time. And this was an issue in a croned world, because it was, you have to give it a minute, or have to give it 2 minutes, or you have to, because if the cron job fires, selects all those rows out, and there's 100 in there, it's going to work that 100, and then it's not going to run again for a while. So it could be 2 minutes, 3 minutes, some undetermined amount of time before the deal updates on the site. And when they're expiring deals, some of the vendors we have relationships with get very sensitive about when a deal is no longer available. They want it marked as such as quickly as possible. And if you tell them you have to wait 10 or 2 or 5 minutes, it doesn't make the relationship work very well. So the immediacy of the changes are much better. Also changes can happen asynchronously, so we can fire off however many workers I want to run. That's how many articles can be being changed at any one time. I think we run 20 dedicated, and then however many are duals do. So this is by far the largest job we have that's back-end work. The next thing we did was we replaced SMTP within our LAN with Gearman. We had issues where, originally we were running, a mail server. We were routing everything out of one primary SMTP server, but we were running an SMTP server on each node. We got complaints randomly that people weren't getting emails that they would, or someone would fill out the advertising contact form, salesman wouldn't get it, and then they'd get an ugly one the next week saying, I emailed you last week, why haven't you emailed me back? And we got to looking, and we found this one web server that it was queuing mail, but it wasn't sending it out. It was just queuing up. So now we're like, how long has this been going on? Because there's a lot of mail queued up. We can't just turn it on, right? So we had to blow away that mail queue on that server. So what we did was we moved to, QMail has a protocol called QMQP, which is basically there's no queue on the server. It connects to a centralized QMQP server, which will have an SMTP server running on. So we went to that. Well, then the problem we had was QMQP would queue the mail on that server for delivery, for an undetermined delivery, be read out of that queue, and then QMail would decide, okay, it's a remote, so then I need to put it in the remote queue. So we were queuing everything twice on the SMTP server. And we also just had a disk issue where we could not, when we were sending our newsletter or our email alerts out, we just couldn't queue stuff fast enough on one node. And the SMTP server was a single point of failure. If the disk failed or the queue got corrupted, which happened about 3 times in a 6-month period one time, you just had to blow away the queue. You couldn't do anything else. Whatever emails were in that queue were just gone. They were lost. You were never getting them back. They were gone. So what we did was we stuck Gearman D in the middle of all this. And we created 2 new SMTP servers that actually are running workers on them. They only do one job called send email. That's all they know how to do. They're the only servers that do it. And anything on our back end that needs to send email queues up a job. And that all goes through Gearman D. That gets the processes that are sending these things done quickly. Our newsletter script doesn't run. Our newsletter script was running for 2 hours, and most of that time was waiting on mail to queue. Part of this is because of PHP's mail function is horrible. It is absolutely terrible. That was the other big problem. And part of it was just waiting on the mail to say, yes, I queued, so you can keep going. And so by pushing it all into Gearman, the running processes are done quicker, and the mail, it can be queued on 2 servers, and it can be, because this is a local queue on this server, it is immediately queued into the remote queue, the way QMail works. It just immediately goes in the remote queue, and can go out. And we did some other things to this QMail build. It's a custom QMail build that lets us partition remote connections by host and things like that helped us in other ways. But it took our newsletter send from 2 hours to about 8 minutes. We blow out tens of thousands of emails in 8 minutes. You can watch the bandwidth graphs just poop, and then they're back going again. Another place we started using Gearman was logging. Everybody starts logging on disk, and that gets you so far. And then you always want to have it in MySQL so you can query it, but you can't really write to MySQL as fast as you need to in a synchronous, reliable way from a web request. We were using a trick for a while. I talked about this on my blog. We were using insert delayed. That's great until you run out of the max insert delayed handlers on the MySQL server, and he just starts throwing those queries away. So that didn't get us really far. We looked at spread and scribe a little, but there's no reliable spread lib for PHP. There's one, but it doesn't work all that well, and it's not compatible with the latest version of the library. And we tried to hire a guy to update it, and he worked on it for like a week, and I don't know, it must be a really bad library because he quit. I don't know. This is a PHP core developer that if you're on internals, you know his name if I said it. So I don't know what that means. So, and I'm not a big fan of Swift. Swift is kind of heavy in my opinion. So anyway, we decided, Gearman's my hammer. So we can, background job log data from anywhere, essentially. And it just queues up in Gearman. And we eventually are going to write it to a MySQL server for us. But if we're under high load, instead of insert delayed flaking out on me because I'm out of delayed handlers, we're going to it's just going to queue up. And it will eventually will get written when everything calms down. And this also allows us to kind of shard the data. So we can shard our data over, however many in MySQL servers we need. We just hash the job ID and send it to wherever it needs to go. So we get a consistent insert rate. The other cool thing this lets us do is this lets us, from our backend applications, query this log data via Gearman. So we can say, give me everything that's happened in this particular event type in this time frame. And then it's not really MapReduce, but that's what everybody thinks it is when I tell them about it. We basically just then fire off additional foreground jobs, asynchronous foreground jobs from that. So there's a worker, there's a job, a worker takes it, and then he creates 2 new jobs that he's now waiting on. Just don't name them the same thing because you can get yourself in a really bad race condition. Did that once. And those 2 servers then find everything they know about, return it to that original worker, he collates the data, and it returns me everything. Now, if you have 100 megabytes of log data that's going to return, that's not going to work well, so you have to make sure whatever you're querying is sane and fits within your memory limits and all those things. But this is really great for our real-time analysis that we're doing, where we are constantly updating how many clicks a deal has gotten, and then that eventually leads to updating the hotness, and that eventually goes back out to the front to the Gearman. So we can collect all these statistics. We're updating. We're building our own analytics because none of the analytics packages, even the commercial ones, really work well for us because the way we work is an affiliate relationship a lot of times where revenue information is delayed 7, 14, 30, even 90 days depending on the type of content it is. And no one can let us assign revenue to an event in the past like that. So we're building our own analytics systems so that we can track revenue, real hardcore revenue, back to the page view that generated it. The entry point, the exact time, the user, they come from Google, do they come from some news site, wherever it is, so we can track that revenue back very specifically. But that much data, parsing that much just visitor data, the analytic data, wasn't doable at all on a schedule, in a scheduled cron, do it at night environment, which was sort of always our go-to method for handling data analysis. You know, we would log it to disk and then collate the logs and then send them off to a processing server, and the processing server would crunch through them and then generate nice reports. We found that it was going to take 18 hours to do yesterday's logs at our current rate with brand new processing servers. So we had to come up with something better. It was still less than a day. So as long as we're ahead of the 24 hours it takes to process 24 hours, if we can do it in a semi-real-time manner, then if you can always process the last 5 minutes in 3 minutes, then you can have what appears to be a real-time information. So we just have to stay ahead of that curve with Moore's Law, and hopefully we can. That was a big, that was huge for us to be able to store logs this way and query logs this way. And there's a whole post on my blog about how we actually do this in MySQL, which is a different talk, if you're interested. But so the most mission critical thing we do with Gearman is what I call request funneling, because I couldn't find a name for it on the internet, so I had to make one up. And this requires you understand a little bit about architecture that's not related to Gearman, so you can understand how Gearman is important. These were 3 different URLs that came from a log of a day we had an outage. And all of these URLs actually are this, right? And the way we were doing the caching at the time was we were just doing URI key generation and creating a memcache key from the URI and sticking that stuff in cache, and that obviously falls apart when you have Google sending this much crap on your URL. That's all from Google. None of that's actually from us. That's just what Google put on there. Coming out of, I think that was out of an ad that our marketing people had put on Google AdWords. So if all we need is this, then we need to know how to build that from whatever garbage we got. So our front-end proxy system is now much smarter, and to deploy an application, you have to actually define what query parameters, post parameters, cookies, and headers are needed for this request. If you don't specify any of those, the backend app server will get the path, and that's all he'll get. He won't get anything else. What that lets us do is that lets us generate one unique URL for every request, and then generate a single cache key and a single job ID for Gearman from that. Yeah, I keep getting ahead of myself. So this is what led to this, right? We had this issue where, I don't know, everything just died. And we had 72 unique URIs for our front page, and there was only 6 possible URLs that we actually needed that involved different query parameters. And then at the same time, now I'm not making this up, at the exact same time, we had an ad running on a very, very, very popular site that's bigger than us. It was actually a Flash 300 by 250 that was making used our syndication API to populate the ad. They turned this ad on, and I guess the ad server thought, oh, I need to fulfill whatever number of impressions in this amount of time frame. I'm just going to put them in every 300 by 250 we have on the whole site. And it had been running for days, so none of it was cached. None of that request was cached. So it all skipped the cache immediately and tried to make hundreds of connections to our application servers, all wanting the same data, which then all made hundreds of connections to the database, all making the same query hundreds of times. The chances of that happening at the same time, I don't know what they are, but they did, and we were out. And we never let the same thing happen twice. So once we have our unique URL, we can create a unique job ID and give it to Gearman. And Gearman will deduplicate that for me. If there's 100, if in this scenario here, only one app server is going to be required to fulfill that. The normalization? Yeah, it does. It happens on our proxy server. So our proxy server does the normalization before it generates the job ID that it then hands to a Gearman middleman that sits between our proxy server and our application servers. So all that gets funneled into one job that gets handled by one worker, which makes a connection to one web server. That back here, these guys just think they're web servers. They think they're still real web servers that get to sit on the internet and do work, but they're not. We're not telling them. Yes. Gearman D. Yeah. So when you generate a job ID for Gearman, if multiple clients all request that same job ID to be run, it doesn't really matter. It doesn't even matter what the payload is. They can be different payload, but the job ID is the same. It will only have one worker do the work, but then will return the answer to everybody that wanted it at the same time. Yeah, sorry. So he was asking who did the Gearman. He was asking what was handling the de-duplication, and that's Gearman D. Yes.
If the payload is the same, isn't the payload like the arguments to the call?
Yeah.
So why would you return the same answer to everything?
It's all based on job ID, because Gearman D doesn't analyze the payload; it just passes it along. So it uses the job ID as the unique key for that work. So it's up to the client to make sure that unique key is unique for that request. That's why we use we actually use the payload as part of our job ID generation for that reason. We essentially JSON encode the payload, whatever it is, and then MD5 hash it, and then put a prefix on it of the job name. So if we do have a collision, we won't, because I've actually seen MD5 hash collisions. It's always fun when a user gets somebody else's page. So this was a huge win and adds 80 milliseconds of latency to our pages when you have to actually go this far. But the scalability wins are phenomenal. It actually reduced the load on these so much that these actually run on the same hardware as these. Because the Apache children on those servers are just so much more bored now than they were before. Because there's this de-duplication, between the de-duplication and the better caching from the normalization of the request. We're able to run the Gearman workers. We run 16 per web node, 16 processes per web node doing nothing but that job. And it's just it takes whatever its input is, it builds a new URI for the actual app server, and then uses live curl to make a request up to the app server. I used to do my own HTTP work in PHP, using FSOC open and all that. And I got really tired of learning every little intricate thing that's broken in the HTTP spec. And plus I think processors have gotten faster, so live curl is not as much overhead as it once was. At one point in time, I could write some I could write code that was faster than live curl, but not anymore. The reason it says important, I'm glad I noticed. In this process, when he's done with his work and he returns it here, he writes it to cache before he returns it to the clients. Because there's a small window from the time the work is done and the job is out of here where other clients could want this work done. And if he writes it to cache before he returns it to them, any new children that come in will find it in cache, and it won't get this far. Learn that the hard way, too. We'd get bursts, and I'd still have this. I'd look at the logs, and there'd still be 20 of the same requests, and I couldn't figure out why. And milliseconds, just milliseconds. And everything goes back out that same way. So that's all I have. And but I'm sure hopefully there's questions.
I have a quick question. So you run 16 workers?
16 workers per Apache server.
Is that because
per physical server?
Is that because you have dual quads hyper threaded, and there you end up with 16 cores?
Those servers I think have 8 cores.
All right.
You're one of those process per core people?
No, on the weekends.
On the weekends? Yeah, you know, yeah. Yeah, I'm not one of those people. But,
Okay.
Yeah. If you are, then don't. We're actually running 4 Apache processes that are running threaded worker. So we're running PHP and a threaded Apache, which is you're not supposed to do that.
Really? Yeah.
Yeah. You're not supposed to do
Brave.
that. Yeah.
One other quick question. So what is the proxy server you use?
We wrote it.
Oh, you wrote it.
Yeah. I can do full PHP session inspection in my proxy, which is really nice.
Is there any reason why you wouldn't? I mean, if you were starting now, is there any reason why you wouldn't use Nginx or something along those
I can't
lines?
make a Gearman request from it.
Right.
I'm not actually proxying he talks HTTP on the front, but he talks Gearman on the back.
Got it. Okay.
So I would have to. I would so love to have an Apache module or any web server that could do this, but I don't have that much spare time, and I'm not that good at C. But if anybody wants a hobby, that'd be a really great one to have. I've been told I could do it with Varnish and like write all the C to do it in Varnish, but because I guess you can inspect the requests kind of like we are and rearrange the query string the way we are if you wanted to. Then you just have to do the Gearman part, which I don't. I guess that could be done. I'm not sure.
One other one. So, so presumably there's only like, while all the pages are quote unquote dynamic, there's like probably 2 or 3 really key critical dynamic pieces of the page.
Yeah.
So, coming at it from a different side, I can imagine there are environments that are similar, that are instead, and when you say caching, what you really mean is memcache, am I?
Yeah,
right?
yeah, we were using memcache.
Right. So are you using any HTTP caching?
It's all HTTP caching.
Sorry, what I mean is reverse proxy.
Like traditional reverse proxy?
No, Squid, Varnish,
no, we're not using
fragments.
any of those. No,
Okay.
okay. You hit our what we call our proxy servers, which are talking HTTP on the front, Gearman on the back, and then it's either found in cache there and returned, or it goes to Gearman to be built.
Is open sourcing the proxy server something?
Yeah, I'd do it. I'd do it. I mean, it requires all the parts. That's why I haven't really jumped into open sourcing it. I open sourced the first one I wrote, which I called Smart Proxy, and turns out it was really dumb because it didn't do the normalization. But it could do edge server. It could do edge side includes though.
Yeah, that was
a really fast way.
That was the reason why I was asking.
It was nice.
Yeah, so that was the reason why I was asking. So a traffic server, Varnish, Squid, they all now have one edge side includes, which is kind of you end up doing similar types of work. Collapsed forwarding, which is basically the scenario where you have Gearman populating the cache before you go out.
Yeah.
So subsequent requests.
Sure.
And more recently the canonicalization.
Do they have de-duplication of requests? Varnish has something. I was talking to Demando, and he was saying Varnish had something close.
Yeah,
I think
he could be right.
Yeah, I don't know.
So
I don't remember now.
I know that Squid does, but it's within a threshold piece. 2 requests come in for the same thing.
Yeah.
That's going to result in a cache miss.
Yeah.
And the expensive cache miss is going to hit to the origin. It'll collapse as long as it's within the window. It'll collapse the requests into one origin request. So to minimize this cache stampede.
Yeah.
But anyway, like I said, you guys have a very different use case, but I can imagine you're kind of doing all of those sorts of things with fewer
places, and you already have, however you're doing invalidation on
Yeah.
Memcache is probably working for you.
Yeah, Memcache is working. When we originally, one of the reasons I originally wrote the first one I had was because I didn't like any of the caching options in Squid, and well, it was really just Squid or Mod Proxy at the time. I mean, this was 6 years ago, I guess. I think I found out about Varnish like the next year or so at Velocity, and the traffic server was not open source until a couple years ago. So I didn't like having, Squid had, each node had its own cache, and you could do some sharing, but it was really weird, and the documentation was really hard to understand. And then I got to this line in the documentation of Squid at the time that said, Squid can act as a reverse proxy, but that's not its intended use. And so I was like, okay, that's exactly what I want to use it for. So that line's not there anymore. I don't know why they removed it, but they did. And so I really liked having my cache in Memcache, where I had one copy of that item, One thing, this is getting a little off track of Gearman, but one of the things we do with our proxy is we have a hard TTL and a soft TTL. Everything actually lives in Memcache for 6 hours, but everything that's cached is actually an array, a PHP array, because the proxy is written in PHP. It's a PHP array, and there's a soft TTL that's one of the parts of that array. And if what is Gearman related? I'm gonna make it Gearman related. If we're within 10% of the TTL timeout, we generate the same job we would generate normally for a cache miss. We just fire as background. Right? So very popular pieces of content on our site, users probably never have to actually wait on them because they're probably being regenerated in the background. And then additionally, if we have something from cache, we will lower our Gearman timeout. Right, so if we're under a load for some reason, he'll actually lower it to like a second or so. To wait for the whole job to be done. And if he doesn't get anything back, he just goes ahead and gives him what he had from cache. Because the job's out there, it's going to get done, right? So it's going to be reloaded into cache soon. So there's no sense in waiting forever for the request to get done. If we don't have a cache, we use our default timeout, which I think is like 10 seconds. We never wait that long ever. But I think we had to for like one legacy old request that did something dumb. I don't know. Yeah, any more questions?
Yes, hi. Two small and quick questions.
Sure.
I guess the first one is, how do you handle Gearman failures? And considering how mission critical Gearman is, how do you sort of do like failovers or sharding or sort of trying to solve the single point of failure?
So originally we used Big IP, F5 Big IP load balancers for a lot of things. We originally tried to run Gearman D behind there using, what's its priority? I can't remember what it's called now. But where we had a primary and then there was a secondary that would fall back to if it was down. We had a lot of connection errors during high traffic spikes, and although the connection graphs and all the stats coming out of the Big IP didn't show any problems, we're still working with F5 on exactly what that was. But so what we actually are using is we have 2 Gearman D servers, and the client code just fails over to the other when it can't, when a connection fails. And we just have the timeout set low enough that, if a connection does fail, then, there's added latency. Sure, if you wait half a second, there's going to be half a second of added latency, but those are the exceptions, and, my phone goes off, and, we get it fixed fairly quickly. But yeah, we run 2 Gearman D servers. We have 2 data centers. We run 2 Gearman D servers per data center, and they're basically it's active. We hash the key, and traditional memcache, modulus hashing for the job ID, just where it goes. That's important because at one point we weren't doing that, and you'd end up with the same job happening twice because the job IDs are obviously only going to be unique per Gearman D server. So if you have 2 Gearman Ds and you send the same job to both of them, it's going to get done twice because they don't know anything about each other. They're just, not very smart, just know how to do one thing, and ask for work to be done and return it to people. So, was that it, the whole question? Sure.
A couple of follow-up questions. What
Sure.
do you use as your persistent backend for Gearman D?
Where the data's stored?
Yeah.
Oh, we actually don't use persistent queues because they're
Okay.
slow as all get out.
Okay.
And we tried to use SQLite and Tokyo Cabinet both. And 2 outages we had in Gearman were Gearman related. Were both related to those libraries throwing errors, not Gearman D. So,
Have you ever tried the MySQL backend, or?
no, I'm worried to be too slow.
Fair enough.
I mean, here's the deal. Where I would be okay to use it would be for the background stuff, which is not that big a deal to just requeue, right? Where I don't want to use it is the stuff where I'm worried about latency, which is also the place where, if the Gearman D goes down, site's down, right? So it's sort of it's a tough nut to crack.
And if you lose one of your Gearman pairs,
Mhm.
all those requests are lost then, right?
Yeah, all those requests would be lost.
Okay.
Yeah.
Interesting.
I believe our proxy server would return I don't think you retry, so I think you would just you'd probably get a 504 gateway not found. So it's a calculated risk.
Sure. No, well, it mitigates a little bit of one of the questions I wanted to ask you, which was sort of how do you monitor the general health? Among other things, John and I both have scar tissue about a home-rolled version of Gearman that did not like jobs backing up. And so whenever the queues get large, we tend to freak out. Is that something you worry about, or is it just Gearman D's fine with that and has lots of queues and it doesn't worry?
I haven't had a lot of trouble with that.
Okay.
I have had trouble with when you're running large jobs that have a large payload and you run a lot of them.
Yep.
Gearman uses a lot of memory because it just keeps everything in memory, and that's that way whether you're using the persistent queue or not, right?
Yep.
The persistent queue is just there as a backup,
Yep.
right? So I guess what Kellen's asking about is Gearman has plugins for persistent queues where the queue data can be stored in some sort of database. MySQL is an option, Tokyo Cabinet. There's even a memcache one that's really, really bad and horrible and should be deleted because it actually walks the queue, walks your cache. I think it uses stats cache dump, or no, it uses what's the totally debug. You're only supposed to use this on your dev box option where you can actually get the cache list out of memcache, which locks your memcache instance while it's getting the list.
What could possibly go wrong?
Do it? Yeah. But it comes with added latency because every queue operation has to be written and read from the persistent layer. But even with that, Gearman still keeps everything in memory as well because it actually does all of its work and decision making and distributing out data out to workers based on what's in memory. Another change I've asked Brian Aker about maybe doing is having payloads larger than X bytes be stored on disk only to solve that problem.
That would be cool. I have one last question, then I'll pass off the mic. Do you have any rules of thumb about how long you let jobs run for? I mean, we try to keep our jobs running really short just to ensure liveliness of the workers.
You mean the actual execution of a
The actual
successful job?
execution time. Do you worry about that at all?
No, our jobs all run pretty quick. You
Okay.
know, our jobs, we try to write jobs that do one little thing and do it really well.
Okay.
We don't have a lot of jobs that, other than like the log gathering job, which that can be kind of big.
Yeah. But even there, you actually write jobs, then write jobs, it sounded like.
Yeah, it will actually have a job that writes a job. And we also do a lot of daisy chaining of jobs. where like the article change job that I've talked about a couple of times, after he's done making sure the front-end database servers have the new data, he'll then fire off an article alert job that will send people email alerts. He'll fire off other stuff, you know. So, yeah, most of our jobs run really, really quick. I mean, our average job time is really pretty quick. So
yeah. You would say like lots of little jobs over one big job is a better way to do it, or lots of little jobs over one big job is a better way to do it?
Yeah, we found that makes everything a lot happier and healthier. Conventional wisdom sometimes tells you that oh, if I'm going to update, if I need data about 100 objects out of my database, I should just run one query and get them all back at one time and work on them, you know. And we use MySQL, and I found that MySQL is pretty happy returning you just a few rows using a primary key or unique key or a key that will, you know, a really well-indexed key, and doing that thousands of times per second. Most of the backlogs I see these days are when you're running a query that's returning thousands of rows. As long as your workers are only doing little jobs like that, you never have the problem of having a random query return 1,000 rows. We've had a problem in some of our code where input validation wasn't checked, and what is normally supposed to select a subset of rows ends up doing a select star from table. You know, and those always turn bad, obviously. And I think that with the speed that you can get out of MySQL in particular, that's what we use. So that's what I know. You can select one or two rows very, very fast. And so that's the main bottleneck with workers. I mean, also depending on your environment. You know, we're in PHP. All of our workers are written in PHP. You just don't want PHP just making new arrays and, you know, loading up memory, and you want him to run his code and get done and clear that function so that the new 5.3 memory manager will free that memory up. So, yeah.
And then, like, an unrelated question. Say somebody pushed out code on the client side that's wrong, and it's queuing up thousands of bad jobs. Yeah. That either just are backing up the queue or are actually doing bad things. Mm-hmm. What would you do?
Well, you stop whatever client is doing that first. Mm-hmm. For us, we don't have a persistent queue, so we look at our status and see what's running. That, you know, is this a good time right this second to kill whatever jobs are in the queue, and you help Gearman. If you had a persistent backend, you could stop Gearman and then manually delete from the persistent backend whatever it is you want gone, and then bring Gearman back up.
So to flush the queue.
When we're using SQLite, I did that a couple of times. That's actually one of the biggest reasons I wanted to do that, was so I could do that type of queue maintenance. But
so you would restart Gearman D to flush the queue? Sorry, you would restart Gearman D to flush the queue? Is there a better way to do that?
Not that I know of. I don't think there's a command to flush the queue.
Okay. Yeah, I haven't found one. So.
Yeah, no, I don't think there's. I don't think there's a command to flush the queue. That'd be a good addition to the protocol, though. Yeah, that would work. Yeah, you could do that.
Yeah, so you
could even use the command line tool to just say, I know how to do this job, and do it, have it do nothing but just return. You know, it would fly through that. Yeah, you can just flush it out. Yeah, you can do that. If you stopped all your real workers and then started a fake worker that didn't do anything, would just suck those out. That's a great idea. Yeah.
Yeah, so we just.
I'd do that. I would do that. That's what I would do.
Yeah, we generally just push like a return at the top of the job.
Yeah, you can do that.
And let it flush it. But I was wondering if there was a better way.
Just hopping on a server and using the Gearman command line would just.
Smart.
They do it too. Yeah.
So you use Gearman for a lot of different types of things, like web requests. caching, I guess,
Yep.
and you do some database writes through it, like updating articles and the critical jobs you were talking about.
Yep.
So do you run all those on the same Gearman D?
Yeah, we just have 2 Gearman Ds per data center,
So
and they're you know,
I'm guessing
both
there's like
running.
different frequency for those things. Like the web requests, I'm sure, are much higher frequency than like database updates.
Sure.
So how do you feel like Gearman handles a load, or like how high does the load get, like requests per second or something like that?
Requests per second for us at peak around our peak season in the holidays.
I don't mean HTTP requests. I mean Gearman
Okay.
jobs per going through Gearman D.
I would have to pull up my Circonus graphs to look and see exactly what those numbers are. But I've never, Gearman's a whole lot like Memcache for me. I just never have any problems out of the daemon itself, really. It's usually, like I say, when I had persistent queue libraries compiled in, and they would fail me, or just a general hardware failure. But Gearman D itself just never really seems to have any problems. I mean, I've kept up with the releases pretty well, and I think I've stayed ahead of some of the, may have stayed ahead of some bugs that maybe some higher volume job users out there have pushed through it, where, I mean, I know I was helping someone in the IRC channel this morning who they're peaking at like 1,000 requests per second for one particular job type. And they're seeing an issue where every 30th job gets sent to 2 workers that we're trying to confirm. It's like the queue management is not keeping up just right or something. And so I'm trying to write a test case to either prove it or not or something, So I think, I've been, like John said, I've been doing this a long time, and I've got a lot of war stories, but we've never been the most popular site on the internet, and we've never had Twitter problems or, that kind of stuff. So there's always been somebody bigger than me, most likely using most of the tools I use, that have hit those walls. And if you stay up to date, if you're that guy who is hitting those walls because you are out in front of the pack, then thanks for finding my bugs for me. That's great. Keeps me up. Let me know where to send the beer. So yeah, it runs solid for me. So.
All right, quick question. So I might have blinders on from being in the Etsy stack, but
Okay.
I never really quite understood the reason for like having synchronous jobs and why you wouldn't just like bypass it and call the underlying, implementation directly.
There could be several reasons for that. That is an architecture choice, right? If you have a piece of code that you're only ever doing synchronously in the foreground, you would have to have an architecture reason, like the server actually doing the work has access to servers that, the server that is wanting the work done doesn't have access to, or it has a particular hardware set that makes it better suited for doing the work, or its locality to the data is better. Those type of things. I mean, if you are ever only running code in a synchronous foreground way, one job, yeah, I mean, you have to have an architecture reason to want to do it that way. And it could also be just a business rule, this is where this happens, sort of, to keep things sane, So, because it could be that, 20% of the time it's done as a background job, but then 80% of the time you need a foreground job. But when you need to be a background job, you just want to be a background job. We have stuff like that. Like there's little changes that some of our staff makes that are making changes to very low traffic sections of our site that we could just write the code, and we were before we were in the Gearman world. We would just write the code in line to update the front-end database servers. But what if the front-end database servers are down? What if the master that gets written to is being power cycled? And that's another reason, right? I mean, if I put it into a Gearman job, then it'll just sit in the queue, and if the worker can't work on it, you'll just wait, and it'll get done eventually. So you get some benefits there from fault tolerance and things like that if you're doing things in workers, in Gearman that will do retries and stuff like that.
Just a quick, there was a article actually towards the end of mine and Kella's time at Flickr. We did actually use Gearman, a tiny, teeny little piece for something that's not really, wasn't really related to the site. But one of the guys that worked for me there wrote actually a pretty good article related to what you just mentioned, which was circumventing security policies with Gearman.
Yeah, I guess it could be used for
that exact
I was talking
way.
about doing it as an architectural choice to improve security, but I guess you could just throw workers out there if you were a snappy young hacker who wanted to get around stuff.
Yeah.
So what you're saying is that's what you did?
No. Actually, the only place that we used Gearman Manager or Gearman, that is, was we would take we would use InnoDB hot backup, but we didn't do, instead of Inno backup at the end where you then go through the apply log phase, so you replay all the events that had happened since the backup had started. We fired that off as a gear. The apply log phase was a Gearman job, so that we could just get on with whatever we were doing, and not like hang up. And because we didn't actually care as long as it didn't take more than 24 hours.
Yeah.
But and then the guy had just the guy had written that, wrote this article. I wrote a blog post about it. We didn't actually hack Yahoo.
You weren't hacking Yahoo?
We didn't hack Yahoo.
Okay.
Yahoo had an entire, no, I'm not going to say that.
Now you gonna say that in the mic? You don't want to say that in the mic?
An entire team of the paranoid.
Yes. I've been fairly language agnostic, except for my brief mentions of PHP tonight. But one of the main ways that I connected with the Etsy guys was I created a piece of code. I don't know really what it's called, but that assists in daemonizing PHP workers. That's what this at the bottom here is. Daemonizing PHP is not for the faint of heart, whichever way you say that. But I've been doing it for a while, and I've gotten it pretty down. And I kept getting people ask me how I did it when I told them I used Gearman and all my workers are in PHP. So I actually took the code we had that was not release ready and made Gearman Manager on a weekend. A couple of months. It's been a year. I don't even know how long it's been now, but. So if you need to run workers with PHP, this is the way I suggest. People in the PHP community keep saying there's got to be a better way, and I agree, there does have to be a better way. Rasmus really would like to see a SAPI written that works like FPM that would manage the workers, and that would be great. If somebody would do it, it'd be better. But this keeps working for everybody, and so nobody's done it yet. So Etsy's using it, and we're using it, and evidently a good number of people. I'm getting lots of. Have you been using that one? Gosh, it was longer than that ago that I made that. Okay, we weren't fully on it until 8 months ago. We were still on the father of this. Yeah, it supports. There's two PHP options for Gearman. There's the PECL extension, and then there's a pair package. It supports both, because I use the pair package, and most everybody else in the world uses the PECL extension. Yeah, PECL. Yeah. I keep wanting to use the PECL one, but I keep not doing it because I can more easily affect the pair code. I'm now the maintainer of the pair package, so it was originally, Joe Stump wrote it originally for Dig. So Gearman and PHP are my hammers.
Are there any other questions? Anything from the world?
All right.
Thanks, Brian.
Thank you, John. Thanks.